All right, final exam cheat sheet, picking up here with problem number 8 on our final exam. In this clip, numbers 8 and 9 on our final exam are both going to come from the exact same chapter and section, Chapter 8, Section 3. This Chapter 8 unit dealt with similarity. And the main punchline here was that traditionally, in a math class, geometry in general actually, we're used to a term called congruence. When two things are congruent, every measurable aspect of one matches every measurable aspect, corresponding measurable aspect in the other. Copy and paste versions of each other. And that's where we get to set things equal to each other, right? So that's congruence. In Chapter 8, we learn about similarity, which is a subtle difference. When two objects are similar, like the two objects that we see here, which happen to be triangles, when two objects are similar, they are what we call scale models of each other. In other words, you get a scale factor, a constant multiplier that will convert, whether through magnification, making it bigger, or minimization, making it smaller, into scale models of each other. The example I used in our notes was comparing a Hot Wheels car to the real life-size vehicle. Okay, the Hot Wheels car is obviously a minimization of the real life car, and what if it is a proper scale model, what will make it look realistic even though it's much smaller is the fact that it will follow a scale factor. If it's what we call a 1/10 scale size, that means that every measurable aspect of the real life regular size car, you would multiply it by 1/10 to get the minimized Hot Wheels version measurement of that same vehicle. And if every measurable aspect is done the same, you are going to see a realistic version just in a much smaller case. And you can see the same thing going the other direction if you take something small and blow it up into something large. Okay, so in this problem, problem number 8, you are going to be shown two figures that you're going to be told are similar to each other, much like you see here. Now, again, on your final exam, they may not be triangles. All that will matter to you are that you're going to be shown two shapes that will be similar to each other, so there's no trick there. And you're going to be given each measurement to each side of the given figure. Again, triangles here, there are 3 measurable sides to each of these shapes. But you're also going to be given this direction. I'm going to talk about this in a minute, but we're going to be told that we're going to be going from this figure here on the left to this figure here on the right. Okay. So in this problem number 8, you're going to be asked to solve for something specific. You're going to be asked to identify the scale factor k that's going to multiply by each of these values and convert it into each of these values. Okay, that's where that direction takes place. All right, so we're going to start here and move this way. So there's going to be something that converts each of these respective numbers into each of these guys. And that value is what we call scale factor k. And this was the main punchline of Chapter 8, Section 3, is that there's some k value, a constant multiplier, that will multiply by each of these respective sides, converting them into each of the respective sides in the smaller version or bigger version, whichever it may be. But here's the piece that we're going to want to know. This is going to be a fraction. All right. K value, our scale factor, is going to create a ratio, a fraction, comparing sides. We need to put it in the following order. Some image length over its original length. So as long as we can identify corresponding pieces, we just simply have to put it into this fraction, reduce the fraction. That's our scale factor k. And again, because we're told immediately at the very beginning of this problem that these two figures are similar, I don't need to check any work or anything like that. I just need to pick one pair of corresponding sides. I don't need to compare them to the other two sides in the case of this being triangles. I don't need to show all 3 sides are corresponding and have the scale factor k. I already know they're similar. I just need to figure out what the k value is. So the simple thing to do here is this. Look in one of your figures, like this one, and pick a value. The simplest thing to do here, pick, say, your largest value, 30. Of these 3 sides, the 30 is the longest side. That's given to us by the fact we just know all the numbers. So the largest side, the longest side in this triangle, is going to correspond to the longest side in this triangle, which of these 3 numbers is this 18. What that means is that this 30 and 18 end up corresponding to each other. So the 30 and the 18 are going to end up being part of my fraction, right? I could have chosen the other guys, and you can end up picking whatever pair you want, but they do have to be corresponding to each other. And so that's why I say just pick the largest value here. So the 30 and the 18 are going to be what's part of my fraction. I just have to make sure I put it in the correct order. So that's where this comes into play. I need to figure out what's the image versus what's the original. And that's where this direction decides that. The fact that I'm starting here and moving this direction, I'm starting here, that makes this the original. So the 30 is going to be the denominator in this k value. So k here is going to equal, again, a fraction. My original length has to be in this triangle. So when I pick the 30, that 30 is going to be down there. The image, the corresponding piece, I already established that 18 was the longest, so this has to be the corresponding piece. This is the image because, again, I'm going this direction. Starting here, ending up here, making this the image shape. So that 18 goes on top. I end up with this. This is technically my scale factor k. The last thing you're just going to be asked to do here is to simplify. 6 goes into top and bottom in this fraction. 6 goes into 18 3 times. 6 goes into 30 5 times. This is my fully reduced scale factor k, 3/5. Just a quick sanity check here. This result makes sense. The fact that it's less than 1, means that it's going to minimize. So the fact that I have a larger triangle here that's getting reduced in size to this one, that is represented and reflected by this k value. Now, had I reversed the direction going this way, all that would happen is that these two values would end up switching. So that would be bigger than 1, making it a larger result. But there's problem number 8. Again, essentially it boils down to identifying k value. It's going to be image length over original length. Pick your longest sides of each of the figures, and you just have to put them in the correct order. So be careful about that direction. Reduce your fraction, done with problem 8. All right, problem number 9, again, is going to come from Chapter 8, Section 3 on similar polygons. And this is really just the next logical step in what we just did. In that last problem, problem number 8, you were given two similar figures, and you need to identify what scale factor k converted one into the other. In this case, we're going to be told, again, that two figures are similar to each other. So in this case, again, we're going to deal with triangles. Again, on your final exam, they may not be triangles. So we're told here that two triangles are similar to each other. This symbol right here means similarity, and that has baggage with it. Okay, that means there is a scale factor k. So you're going to be shown those two figures. So we have triangle DEF and then triangle MNP, which is quite obviously a much larger version of the other. And you're going to be told some of the lengths here. But what's going to be different about this problem from the last one is that in this case, you're going to be given an unknown x. And this x value is what we're going to be needing to solve for. But you'll be given everything else. We're given every other length here. And so in the last problem, problem 8, you had to identify the scale factor k. In this problem, problem number 9, we're going to be using scale factor k to show that, well, any corresponding piece, whatever converts this 15 to this 18, for instance, has to be the same conversion that converts the 20 to 24, and whatever my unknown value is to this 30. So let's jump into that. Again, using scale factor k, because these two shapes are similar to each other, as given by this symbol right here, because these two shapes are similar, every corresponding piece, and so this DE, for instance, right here, is going to correspond to MN, this guy right here. Keep erasing my values here. But because of this, I'm going to end up with the following thing, that each corresponding side is going to convert into the other. And I'm going to make an equation that does that so I can solve for my missing piece, my missing variable. So first thing I'm going to start with here is my x value, side EF. EF are the last two letters in this guy. They're going to have to correspond with the last two letters in this guy. EF to NP. And visually here, they're oriented the same way, so we can see that. This guy is going to correspond to the 30. So geometrically speaking, EF to NP, what's going to convert this guy to this guy, these are corresponding pieces. This is going to represent some scale factor k. That has to match each of the other respective sides to the other. Now, I don't need to show all three sides being related to each other, so I'll just pick another pair. So let's go with the DE side here. DE, the first two letters here, to MN, these guys here. So MN. Geometrically, this has to be true. Because they're similar, whatever these corresponding pieces, whatever they reduce to, the scale factor K needs to match every other pair of sides. So now I'm just plugging values in. EF is this X value, and P is this 30 value. That's going to equal DE, which is this 15 right here, over MN, which is this 18 here. And for the record, if I were to reduce 15 over 18, that would give me the scale factor K. That would move me from one triangle to the other. This is just setting up because whatever value is up here has to reduce to the same scale factor K. Well, in order to solve for X here, I just need to move this 30. The 30 is being divided here, so I'm going to multiply it up here. Take a step to do that. So X here is going to equal that 15 over 18 times 30. And because they're fractions, technically this is 30 over 1, right? So when I multiply these together, that's what I'm going to end up doing. But this is just calculator work. I'm going to do 15 times 30 and then ultimately divide it by 18. So 15 times 30, there's my numerator, divided by 18. X is 25. And for the record, had I reduced 15 over 18, 3 would go into top and bottom, this reduced to 5 over 6. That would be the conversion that converts the larger triangle back to the smaller one. And if I were to do 25 over 30, that would also reduce to that 5 over 6, the same scale factor K. So a quick sanity check here. Does this 25 value make sense? If I look back at the original figures, you'll notice that each of these guys is smaller than their respective counterparts. So the fact that I got 25 here should be smaller than this 30 unit length. And that matched up. So that worked out. So there's problem number 9. Again, 8 and 9 both come from chapter 8, section 3. Number 8, you're going to be asked to identify the scale factor K. In number 9, this problem, you'll be asked to use that scale factor K, basically these ratios, these comparisons, to identify some missing length. But I'll go ahead and stop our recording right there.